We could also have situations dealing with solving equations where we do have more maybe complicated expressions to work with. So I've got one like 2 times x plus 5 in parentheses plus 3x equals 20. I can still apply my rules to solving an equation going top to bottom, but now I do have to apply the distributive property. And for me, I actually do often write arrows of saying, okay, well, that means that this 2 is being multiplied by the x and the plus 5 here. But if you don't need that and you can rationalize and remember that I need to multiply by everything in the parentheses, then that's fine. So 2 times x, that's 2x. 2 times plus 5 is plus 10. I still have my plus 3x, and that still equals 20. All right. And the reason that I didn't do anything to both sides is that I'm not actually performing any adjustment to the equation right now. I am actually doing something more like simplification. Okay. So now looking at this next statement, combining like terms on each side of the equation. Well, I could rearrange this to get the like terms together because remember, I'm looking for either constants on the same side or variables that have the same degree. So 2x and 3x, those are common or like terms. Okay, so if I put them together, it makes it a little easier to see that I'm going to group these and do this addition. So 2x plus 3x, that's 5x plus 10 equals 20. And now we go through and look and say, okay, well, I've done step 1, there's no distributive to do. I've done step 2, there's nothing to combine. Step 3, additive principle or addition principle. I have a plus 10 that I need to get rid of. So the opposite of addition is subtraction. So if I'm adding 10, I then need to subtract 10, and now I do need to do that to both sides because I am actually putting in a new part of the equation. And then once I've done my addition of subtraction, or subtraction if you want, to both sides, now I can simplify. So plus 10 minus 10, that becomes, again, this is 0, so I don't need to worry about him. So then I'm left with 5x on the left-hand side, and then 20 minus 10 is 10 on the right-hand side. And now last step, I have a 5 that's being multiplied by x out in front. So if I divide both sides by 5, that'll get rid of the 5 on the left-hand side. That'll leave me with just x. And then 10 divided by 5, or 10 over 5, reduces to 2. So x equals 2 is the solution to this equation. And again, we could check this. We could plug in our value of x equals 2 into our equation, and if we did, we would have 2 times 2 plus 5 plus 3 times 2 equals 20. Order of operations comes back into play, so I do the stuff in parentheses first. Here, 2 plus 5, that's 7. It's being multiplied by 2. And then 3 times 2 equals 20. 2 times 7 is 14. And 3 times 2 is 6 equals 20. And you know what? I'm supposed to put a little question mark above the equals because I don't know that they're equal until I do my final check. 14 plus 6 is 20 equals 20, and yes, that check works out. So x equals 2 is the solution to the equation 2 times x plus 5 plus 3x equals 20.